We are continuing with the problem with where we had stopped. So the continuation of the previous problem where you have to find out what is the resultant force on charge at D. From here we have already found out what is the force acting on D due to A, which was 3.6 Newton, and it was known that this force was along AD. We also found out the force acting on D due to B, and we found out this force was along BD. I think this has to be again corrected. It is along BD, not along AD. Okay, we have got it along BD. And then we found out what is the force on D due to C, which is 10.8 Newton, and it was along DC. Remember, it was a negative charge, so we got it from D to C. So this is where we had stopped in the previous problem. So we are continuing it further from here. Now, since we have all these three forces which are acting in three different directions, we know that the angle between these two forces, that is what we have over here, I can easily say is a diagonal which is bisecting this angle over here. So it is clear that this angle should be equal to 45 degrees, and this angle now should create in value which is equal to 45 degrees because it is opposite angles. So now I can resolve FDB and FDA, that is on resolution I get FDB which is cos 45 and FDB which is sine of 45. So net force AD, that is F1, I'll take it as FDA plus FDB cos of 45 is equal to 3.6, and cos of 45 is 1 by root 2, so I'll substitute that value which is 3.6 into 1 by root 2. So F1 is found out to be 6.146 Newton, and it is a net force along AD. So let us replace this by F1 which is along AD, and now let us find net force along DC. Now net force along DC let us consider as F2, where F2 is nothing but FDC minus FDB sine of 45. Now FDB is into the negative quadrant shown by that green line which is FDB sine of 45. So if I simplify, we know FDC is 10.8 Newton minus FDC which is 3.6 into sine of 45 which is 1 by root 2. So I simplify this value to get F2 is equal to 8.254 Newton. So we have even simplified this value to get F2. So it is known that F2, which is 8.254, is along DC. So value of F2 as well as F1 is known. Now from these two values, that is since we have calculated F1 as well as F2, we can now find out what should be the resultant force of the. So to find the resultant force of F1 and F2, we will use parallelogram law of vector addition. So we'll construct a parallelogram, draw a diagonal from the center or from the point where the two forces are joining, and this resultant force which will be represented by F. So here I'm using this formula which is R is equal to root of P squared plus Q squared plus 2PQ cos theta. Remember, theta is the angle between F1 and F2. So F is equal to root of F1 squared plus F2 squared plus 2F1 F2 cos theta. Substitute your values. F1 is 6.146 the whole square plus F2 which is 8.254 the whole square plus 2 into 6.146 into 8.254 into cos of 90. 90 is the angle between F1 and F2. Since cos of 90 is equal to 0, the whole term on the other side should be equal to 0. So I get F is equal to root of 6.146 whole square plus 8.254 the whole square. And on simplifying, I'll get F is equal to root of 6.146 whole square plus 8.254 whole square. Should give me 37.77, and find the root of this value, plus 68.12. Find the root of this value. we should get it as 105.89, which is equal to 10.29 Newton, which happens to be the resultant force which is acting on D. So we have found out what is the resultant force. Last thing what I'll have to find is the direction. Now to find the direction, which I'm going to represent it by alpha, so let us say alpha is the angle between resultant force F and F1. Using the formula tan of alpha is equal to q sin theta upon p plus q cos theta, let us consider F1 to be P and F2 to be Q. So I get tan of alpha is equal to F2 sin theta upon F1 plus F2 cos theta. Please substitute those values. We should get F2 sin 90 upon F1 plus F2 cos 90. We know cos of 90 is equal to 0 degrees. So tan of alpha is equal to F2 sin of 90, where sin of 90 is equal to 1. So F2 divided by F1, and since cos of 90 is equal to 0, the whole term related to F2 is cancelled. So your term is only tan of alpha is equal to F2 by F1. So in simplifying, you will get F2, which is divided by F1, should give you 8.254 divided by 6.146 is equal to 1.3422. Therefore, tan alpha is equal to 1.3422, or alpha is equal to tan inverse of 1.3422, where using logarithm tables you can easily find what should be the value for alpha. Alpha is equal to 53 degrees and 19 minutes, which is the direction. Hence you can say it is a direction with respect to F1. And if you even find out 90 degrees minus alpha, you will get what direction it is making with F2.